The scientific method is basically applied logic. It's using problem solving to figure out what's wrong with something, how things work, and in doing so, it provides a nice systematic way of solving these problems. The scientific method is something that you guys probably use in everyday life. Scientific method is often found when, your car doesn't start in the morning. Why isn't my car starting in the morning? Okay? And the way this works is that first you identify something that's so it's an observation. You start with an observation. Observation would be something like, why do birds fly north for the winter? Okay? Why do some people get sick from a certain bacteria versus other people? Okay? What's the difference going on there? In this case, I'm going to pick something simple from everyday life. Why isn't my car starting? Alright. So why won't my car start? Okay. The next thing that comes up is I've got to develop a hypothesis. And the hypothesis is a guess as to how to solve the particular problem. Okay. So for a hypothesis, I look at this and I say, why won't my car start? Hypothesis, I'm out of gas. Okay? Or even worse, my pen doesn't work. Now this is a statement, this is a declaration, right? I'm declaring that my car is out of gas. But this is hypothesis, so it's a guess. So you don't want to say, I'm out of gas. You want to say, I'm out of gas. Okay? That means the question mark is applied there. So to look at this, I've now got this question. All right? I'm out of gas. Now, how am I going to test to see if I'm truly out of gas? Okay? You can open up your gas tank and smell, but there might be a residual smell from gas that was in there previously. Okay? And so you smell, see if that's in there. Or you can take a dipstick with a cloth on the end, put it in there, pull it out, and see if that cloth is soaked with gasoline. All right? And if the gasoline is soaked in there, then you look at that and you say, all right, well, I'm out of gas, but my cloth that I used to test this, right? And that's my experiment. My cloth on a stick, my dipstick at this point, I used to test to see if there's fuel in there. I put that in, and it came back one of two possibilities. Okay? I'm using my dipstick to test for gas. Okay? So I test to get for gas at that point, and I check that out and see what's going on. And I've got two possible options. Okay? First option is that it's wet. Okay? And the second option is that the dipstick is dry. What that means is I have two possible outcomes for this experiment. Now look at my experiment and say, is it wet? Is it dry? Well, if it's wet, that means I've got gas in there. So at this point, my hypothesis has been proven false. Okay? Now this is an important part of science, is that sometimes you're going to make a hypothesis, your hypothesis is going to be wrong. There's nothing wrong with that. And there's a lot of people who are out there in science right now who have a significant issue with being proved false. And that's because they put a lot of time and a lot of money into their research. And if their research is wrong, they've wasted all that time and all that effort. So people in science, they don't like being proven wrong. Well, guess what? You entered into science, sometimes you're going to be proven wrong. If that's the case, you got to check your ego. You can check your ego, look at that, and say, you know what? The idea was wrong. If that's the case, it shouldn't be a big deal because you're still doing science. So you look at this and say, it's false. All right, what am I going to do at that point? You quit and become a burger chef, right? Of course. No, what do? You go back to the start. So if this has been proven false, you come back up here and you have to develop another hypothesis. Okay? Not something that's entirely unusual in science. Okay? If it's dry, however, you look at your gas tank, and if it's dry, you have a true statement at that point. Alright? So you have a true statement. Once you get to that true statement, once your experiment has verified that something's true, you reach a point that's called theory. Alright? You'll hear about people, they'll sit there and say, I have a theory. And you see that in television movies all the time, talking to your friends. I have a theory as to why this is happening. No, you don't have a theory, you have a hypothesis because you haven't done any experimentation yet. And then you can hit him in the back of the head and say, Dr. Roy said I could hit you in the back of the head. Sorry about that. Don't sue him. He's on a video. Okay? The theory, okay, means that you have a positive result from experimentation and it's leading down this road. Okay? Does this mean that the theory is true? No, it means that the theory is the best set of information to solve the problem that's going on. Does your car not start because it's out of gas? Maybe, maybe not. Okay? There's still a variety of different things. I mean, if you fill it with gas and you're like, you get there, you turn the engine. If it doesn't work, then the problem with your car, the original observation, the original problem, why won't my car start, isn't because you're out of gas. It's because of a different problem. You identified one small problem, but that wasn't the core, that wasn't the answer to the observation that you had. Okay? So what this means is that once that's true, I have to do another experiment. What's the second experiment at this point? All right? I just told you, fill with gas. In this is additional experimentation. Okay? So this is more experimentation. Good theory is surrounded by a lot of challenging experimentation. You have to challenge and make sure that your theory is right. If your theory is not right, then you'll be sending science down a rabbit hole, right? You'll be sending it down a rabbit hole and trying to figure out what's going on and if this works. If it's a rabbit hole, you're testing the wrong stuff. All right? So that's why you have to do vigorous experimentation to verify a theory. Okay? Okay, so now I fill it with gas. I turn the key, my car starts. All right, then yes, I was out of gas. If I turn it and it doesn't start, then there's something else that's wrong with the car. This was an observation that was true, but it didn't solve the actual underlying problem of why my car didn't start. Okay? Okay, so there's always further experimentation that comes with it. If I get something that's false, what do I have to do? I have to change my hypothesis. My car won't start because my battery's dead. My car won't start because somebody stole the engine in the middle of the night. Okay? What do? You can pop the hood, see if the engine's still there, right? That's the experimental part. You do this all the time. And what I challenge you guys to do is when you're out there in real life, try to apply the scientific method to basic everyday tasks. Keep a journal. Okay? Do it on your phone. Keep a journal or something like that. Identify when you found science. The more that you identify what you are doing as science, the more you're going to feel like a scientist. And guess what? The smarter you're going to be. Have you ever heard Einstein's idea, or I think it was Einstein. I'm not really sure if it's true that it was attributed to him, but he said that the definition of insanity is doing the same thing over and over and over again. All right? Insanity, I come down here, I'm out of gas, I'm going to add gas. Okay? So I keep adding gas and keep adding gas. And my car still won't start. I must be mad not adding enough gas. And keep adding gas, and there's gas all over the place. And you don't know what's going on. You keep adding gas, and guess what? You look at somebody doing that, you think they're crazy, right? Well, that's kind of a crazy idea. Okay, so you see that by applying the scientific method, even in everyday life, including in science, you want to look at things and you always want to challenge the ideas that you've got. Science is all about challenging ideas. Okay. All right, there's one thing I do want to mention about scientific method before we're done with this video, and that's the idea of theory versus law. Right? We've seen that theory is something that is sort of a living organism. You always want to test it and fine-tune and get down to where the theory is best applied. Okay? The theory of relativity, for example. We have really a good idea how it works. We're not really ready to say that we have a full concrete grasp of what's going on. Okay? Laws in science are immutable. Okay? Always true. And guess what? A lot of scientists nowadays, they don't like saying things are laws. The reason being is that they're used to the idea of theory. Okay? A theory can be fine-tuned to the best idea that we've got. For example, the theory of evolution. The theory of evolution, it's a theory. It is not a law. Okay? The theory of evolution is the best description that science has for describing why certain types of organisms turn into more complex organisms. All right? This is not something that's observed in the laboratory because we don't have 10 million years sitting around watching things in a petri dish. Okay? Evolution is a theory. Okay? It's the best theory that we've got for describing life. All right? It does not mean that it's a law, like the laws of thermodynamics. Okay? You can't destroy or create energy. Right? That's a law according to thermodynamics. Okay? There's a couple other laws, and those are laws that we look at and we kind of hold dear. Because those laws, Newton's laws of motion, for example, Newton's laws of motion are no longer laws. They're theories of motion. Because Einstein disproved that with relativity. Okay? Not everything moves according to Newton's laws when you get to relativistic speeds. And when you get to the quantum level, everything kind of gets fuzzy as far as those laws go. Okay? So it's more like Newton's theories of motion. Okay? We generally try not to talk about things as far as scientific laws anymore, simply because we like to hedge our bets and make sure that we're onto some sort of great idea.